In this video, we're going to continue talking about antiderivatives, but specifically we're going to talk about the process of integration. So here, let f be any antiderivative of, so capital F is any antiderivative of lowercase f on an interval I. The indefinite integral, okay, so our indefinite integral of f with respect to x is defined by, so we have this notation. And so the indefinite integral of little f of x with respect to x, right, so dx, so we're integrating it with respect to x, is any antiderivative of f, then plus that arbitrary constant. And so this is any specific antiderivative, and then plus c. So typically the specific antiderivative, we use the constant, the specific constant as 0, and then we tack on that plus c. All right, so let's look at some examples. Here we are integrating 4x plus 2. We want to find out what function has 4x plus 2 as a derivative. So 4x, that came from an x squared, but it would have had to have come from 2x squared. And 2 is the derivative of 2x. And then don't forget the plus c. There we have integrated the function 4x plus 2 with respect to x. Next, we want to integrate 1 plus secant squared x dx. So what is 1 the derivative of? 1 is the derivative of just x itself. Secant squared, that is the derivative of tangent of x. And then don't forget plus c. That is our process of integration. And so as you might imagine, all of the derivative rules that we had before, for the most part, at least the simpler derivative rules, we have an integration rule that will be its counterpart. So let's look at some integration rules, some basic integration rules. All right, if we were going to integrate 0 dx, right, so what function has 0 as a derivative? So remember, 0 is the derivative of any constant, and so when you integrate 0, you're going to just get that arbitrary constant c. Right, so that will integrate to c itself. What if it's a constant other than 0, some value k? What does that look like? Well, that's going to integrate to k times x, and then plus c. Great. What if we want to integrate k times f of x, where k, again, is just some constant? Well, here we're not going to come up with an answer because that f of x is still way too general, but the rule that we want to be aware of is that constant, we can bring that out in front of the integral. And then we can just integrate f of x itself and then multiply it by k. Similarly, if we have the sum or difference of two functions, then we can split those up and integrate f of x with respect to x, and then add or subtract from that g of x with respect to x. Okay. So those are some of our basic integration rules. This next one, we will use this one a whole lot. This is going to be kind of the reverse of that power rule for derivatives. So if we're integrating x raised to a power, right, raised to a fixed power, then what are we going to do? Well, we are going to, so it would have had to come from a power that is 1 larger than it. So we will add 1 to the power, and we will divide by the new power. So it looks like that. Now, you should note this is only okay for n not equal to -1, right? Notice if n was -1, when you add 1 to that power and divide by that new power, you're dividing by a 0. So that behaves differently. This works for everything except for n being equal to -1. Excellent. All right, let's keep on going. Over here to the right, we have cosine of x. What is cosine the derivative of? It's the derivative of sine x plus c. Sine is the derivative of negative cosine x plus c. Secant squared is the derivative of tangent x plus c. Secant times tangent is the derivative of secant x plus c. Cosecant squared is the derivative of negative cotangent x. And cosecant cotangent is the derivative of negative cosecant x plus c. So we have all of these basic integration rules. Just like you learned all of your differentiation rules, you need to get these integration rules down as quickly as you can. You will use those continually throughout the remainder of integration. These kinds of ideas will show up in a variety of different places in different ways. Now, one thing that you might notice is I didn't write down a rule for f of x times g of x dx. So I didn't write down a rule that says that that is equal to f of x dx times the integral of g of x dx. Why don't you think I wrote that rule down? Well, I didn't write it down because it's not a rule. That's not a thing, right? So just like we had a special derivative rule for products, if we're trying to integrate a product, we have to do some special stuff. Similarly with quotients, we have a special derivative rule for quotients, and so if we're trying to integrate a quotient of two things, f of x divided by g of x, we can't just integrate those two things separately and then smash them together. We have to be really careful about that. We have to treat those carefully. But we will wait on those till some future videos. We will talk about how we might approach some of those. All right. In our next video, we will look at some more examples that are maybe a little bit trickier, that might require us to do a little bit of algebra or trig on the front end before we get into being able to solve it. But overall, these are the integration rules that we are going to have to play with. And so if it doesn't fall into one of those, we don't have the tools yet on how to solve those. All right, we will see you in our next video.